Hello, everybody. Welcome to another KIELive session. I hope you're doing all well over there, and it's great to have you here today with us. Remember that you can always share your questions, your comments on the chat. We'll be here waiting for it. And today we are going to talk about how you can optimize the way you assign human tasks in business processes by using an optimized plan. We have today here a developer with more than 20 years of experience, and only in the business automation space, he has more than 10 years of development as part of Red Hat itself. He's worked as a Java instructor, sales architect, working across the globe with many different projects. But today he's a core developer in OptaPlanner. He's Walter, and I'm going to bring him to stage. Hey, Walter, how are you doing?
Hello, Karina. How are you? I'm very happy, I have to say. I was a bit nervous the other day, but now I'm very happy to be here. So thank you so much for having me here, Karina.
Oh, that is awesome. And the thing that we have to show today is quite interesting because we already have the solution for the JBPM based processes, let's put it like that. So we can already do the solution for JBPM and RHPM. But today, Walter is going to show how we can optimize the tasks in Kogito based processes. Right, Walter?
Yeah. Yeah, today basically this presentation will be focused by one side in OptaPlanner, also in Kogito processes. But I believe that the most important thing of today's talk is that we will see how these two things can be combined in order to provide, let's say, a different approach to the task assignments in the business process management, right? So I believe that this is more or less the most important thing, right? To combine all the things and to provide a new approach. Of course, this new approach is something that people can use or not. But what we are giving is another possibility to the business process management business by using our tooling. So this
That
is
is
more or
awesome.
less what we'll be talking about today, Karina.
Yeah, that is awesome. And also because I want people here that are going to watch today to understand that the Cogito-based processes, they are deployed in a microservices way. So it works a bit different from the JBPM-based processes, and you will see how OptaPlanner can actually come into this different architecture and actually leverage things from the architecture itself to optimize the way we do human tasks in business processes. So, Walter, I think enough talking, right? And
Yeah.
I think we can get started. What do you think?
Okay, let's go. Very good point. This last thing you say, Karina, I will try to emphasize during the presentation because Cogito is something, completely different that really changed the way we work with business process management, right? So I will try to emphasize this at some point. And of course, if you want to add something in the middle, just let me know, this trick we need to do with the presentation, the screen sharing, and go ahead, okay?
Okay, awesome. So you can share your screen now. And
Okay, thank you.
guys, just as you know, just share any comments, any questions on the chat, and we'll be here with you during the whole presentation. Walter, you can get started now. Thank you.
Yeah, so I say more or less that we will be talking about OptaPlanner, the Kogito business processes and how these two things can be mixed or combined in order to provide a different approach to the task assignments, right? So I will go very, very quick with the, normally when we have business processes, right, and we work with user tasks, a piece of the task configuration normally indicates which is the group of users that we expect to work on this task, right? This screen here is something is a screenshot from the Cogito tooling. But if you go to other vendor or other tool or to Business Central, you will always find some equivalent definition here, right? So this is part of the task configuration. So in general, when we work with the standard way of assigning tasks in business process management, What we will have is that when your different processes start creating the different tasks, by one side you will have the task, and on the other side you will have the users that want to work on this task, right? But in general, given the specification or given the configuration that we saw, really the tasks that we have here are assigned to a group of users, and nobody is really the owner. This is something that remains constant over whatever vendor or implementer you have. Different vendors or products, etc., might have different ways or different tools in order to show this information to the users. But this thing here is something that is common to all implementation. So in order for these users to work with the tasks, really the users needs to pick the tasks by themselves, right? This is something that we normally call the claim operation. But you must imagine, Karina, that in a, let's say, in a real system, normally this list here tends to be huge. And also you can have tasks for different processes, right? For different businesses. So really this list here can be huge, right? Of course, if user John wants to work with a task, he needs also to pick the task from the list. And really, what we have in the standard way of working with the task is that the responsibility of the task selection is delegated to the users. Delegated to the users that needs to go completely through a manual procedure. This is not an issue at all, right? That's the way we work in standard business process management. All implementers work this way, and this is not an issue. But really, the question that we did ourselves in OptaPlanner is, okay, how about to automatically assign this task? So instead of users having to go through a list and start picking tasks manually, how about if we can instead, let's say, feed every user with a piece of the work to do, right? How about if we go to a different approach? If we can go to this approach, then Mary can focus on completing only the tasks that we have assigned to her, and the same to John, right? It's a what we are doing is an inversion of control, right? So if we can go to this approach, then what we are doing is delegating the responsibility to an algorithm. So what we want is really to use an algorithm in order to calculate and produce these assignments. If we can do this, of course, this algorithm need to respect the process semantic, right? We don't want, for example, this task assigned to Paul here because he's not a manager in this case. If we could delegate to an algorithm, maybe we can start introducing certain, let's say, optimization criteria to this algorithm. Maybe we want to instruct the algorithm to start assigning high-end priorities first, high-end priority tasks first. Maybe, try to put the higher priority task in the head of this list, right? Maybe also try to start minimize the task maintenance. What does it mean? It means that, let's say, from the point of view of the business, we need to complete all the tasks. So the idea is to tell this algorithm that we want to complete all the tasks as soon as possible. So the first implication of this is really that the algorithm needs somehow to start doing a kind of fair balancing between the users, right? We don't want that all the tasks are assigned to Mary and 0 tasks to John, right? This is not fair from the employee perspective. But if we do this, what we will have is the time to complete all the tasks will be bigger. And of course, this potential algorithm, we want that ideally this potential algorithm could consider other business-related information for doing the calculations and the ordering and distribution of this task, right? So this is more or less what this presentation is about. So the next question, so in other words, really we are talking about an optimized plan, right? Distribute the task, consider priorities, minimize the baseline, eventually consider more business-related information. This last point here is very important because to consider business information for the task assignment and distribution, this is only something that is not possible really with the standard business process management approach, right? So the next question that we have here, okay, is why to use OptaPlanner then? Well, the answer is quite obvious, really, OptaPlanner, but what I mean is that OptaPlanner is a well-proven technology. It has been there outside for years, and we have many customers and users working on different optimization problems that are using OptaPlanner successfully. And really the list of use cases that we can tackle with OptaPlanner is huge, right? It's really huge. It ranges from the employee rostering, vehicle routing, but also if you look here at the bottom of the list, recently OptaPlanner was challenged to tackle the optimization problem of coordinating the vaccination scheduling for different persons around the world, and this is really being used right now. They're outside, right? So yeah, the first thing is quite obvious. Really, OptaPlanner is the good place to start, right? Also, another thing that is important for us in OptaPlanner is to consider more and more use cases and problem domains, right? Really, the task assigning problem is not new for OptaPlanner. We have already examples, we have already use cases, for example, regarding call centers, etc., that really shows that OptaPlanner can tackle this problem, right? But what we want here is okay, we know that the task assigning problem is something that OptaPlanner can deal with, right? But what we really want here is, okay, can we also jump with OptaPlanner into the business process management domain? And this is very important for us because if we can do this, right, when you go to Kogito and build your business automation solutions, then you can combine, for example, rules, DMN, of course, the business processes, and also OptaPlanner. And we believe that to combine all these things in a business automation solution in Kogito is something that could be interesting for many people that are outside. And lastly, another thing that is important for us in OptaPlanner is to continue challenging the product itself, right? This is something that the guys in the teams are really doing all the time. Not me. I'm really, to be honest, I'm a beginner in OptaPlanner, somehow a beginner, right? But the people in the team is continuously challenging the problem, right? Right now, there are people working, for example, playing about how to use OptaPlanner from Python, how to integrate micrometer. This is something that we need to continue doing OptaPlanner in order to evolve the product, right? And continue making the product grow. Sorry. So here is when the name Quarkus come into the scene, right? Because right now we have an OptaPlanner Quarkus extension. Right now there are people that are outside that is using OptaPlanner with Quarkus, right? But even so, we want to continue stressing this the Quarkus extension. We want to continue using it to identify potential improvement areas, identify, potential issues, etc. So this is important for us. Kogito is something also very important for us because what we want to know is that what happened, for example, when people that are outside are creating their Quarkus applications based on OptaPlanner, and they want to interact with the different Kogito services, right? Do we have any gaps there? Is it difficult? Is it complex to interact with these services? And of course, we want to know if it's also possible to develop Kogito services purely on top of OptaPlanner. And the last thing that is important for us that come into the scene is Kafka, right? Right now, we know that real-time planning is possible in OptaPlanner. Real-time planning means that OptaPlanner can react to a change in context. For example, You create a new task, you complete a task, you assign a task from one user to the other. I will try to show this now running, but this is also important for us because we want to know if these real-time planning scenarios that we can implement nowadays, we want to know if it's possible to implement them also when we move to Kogito and start consuming the Kafka events produced by the different Kogito services. Did we made it? Yeah, I think we made something reasonably good, I have to say. So this is a very simplified picture of a Kogito deployment, right? When you go to Kogito, it's important to say that, Kogito have many different building blocks or elements that you can use that are completely optional. In this picture here, basically what I'm showing is a business process, hello world, that is generated into a Kogito application, right? So what Kogito will do for us automatically is to create some endpoints in order to work with this process. But with Kogito, we can also integrate with Kafka. And one of the components or one of the services that we have in Kogito, for example, is the data index, right? This element here basically can consume the events that comes from the Kogito processes in order to index the data so that users can be able to query the the task information, etc. And this is the player that we are presenting now, right? The task assigning service is a Kogito service that we created on top of OptaPlanner. And really, OptaPlanner is the heart of the task assigning service, right? So all the decisions that are happening there inside are calculated and decided by OptaPlanner. So typically, the cycle that we have here is that when new process instances are created, events are produced that are consumed by the different Kogito services, for example, by the task assigning service. OptaPlanner is doing calculations, and depending on these calculations, we will finally produce the task assignments that I was referring to. But I think that the best way is to see it working. So let me jump to something more. Yeah, let me jump to the application. What I will do now first is to start creating some process instances, right? But we in the standard business process management assignment mode, right? I will use Kogito, and here I will create some instances for this simple process that I showed before. This simple process has one single task that is the task for managers. For the demonstration purposes, I think it's good. So I will use the Swagger UI for creating some process instances. This is something that you can get out of the box with Kogito. You don't have to program a specific UI for creating processes. For demonstration purposes, you can use this if you want. So let me first show the current task inbox that we have in Kogito. And here, for example, I'm showing the user John, right? At this moment, we can see that there are no tasks for John. And if we go to Mary, we can see the same, right? No task for John, no task for Mary. This is because there are no tasks in Kogito right now. So I will create 3 tasks, for example. So now if we go to the task inbox, we will see that Mary, for example, let me see. Yeah, I'm using the wrong method, right? Okay. Let me create the instances, 1, 2, 3. Let me go back to the task inbox. And now we can see that right now in the system, we have 3 tasks, right? We have the task create for managers. We know that is for the manager group, and we know that Mary is a manager, okay? If we go to John, we can see the same thing, right? This is the standard business process management mode. If John wants to work with this task, then he needs to claim for the task. Let me remove this. Okay, so here we have John. We can see that the tasks are in the ready status. This is because when a task is created in Kogito, it is assigned to nobody. It is assigned to the group. And the task is in the ready status in order to the different users start picking the task to work. Now I will start the task assigning service. At this moment, the task assigning service is stopped. It's not running. So I will start it, and I will go back to this list and see how the things start changing as soon OptaPlanner starts doing calculation and producing assignments. All right, this already started. Don't waste time here, but here we can start seeing some logs from OptaPlanner, so things are working well, right? When I go back to the task list and I refresh this information here, now we can see that for John we have only one task, and that is reserved. It means that this assignment that I was referring to was automatically produced. On the other hand, if we go to Mary, now we will see that we have two tasks reserved for this user. Again, what we have here is that a formal assignment was produced, and this was produced by OptaPlanner by OptaPlanner through the task assigning service. So I said some moments ago that OptaPlanner is the heart of the task assigning service. So let's look inside OptaPlanner and try to see what's going on there inside. So in this other screen here, what we will see is exactly what's going on inside OptaPlanner. We can see that OptaPlanner has a lot of information, but we can see that here we have the information about the users that we have now in the system. OptaPlanner at this moment knows exactly that Mary is a manager, knows that John is a manager, but also an employee. And of course, we have the information of the task that I created before, right? So here we can see the internal work distribution that is being calculated by OptaPlanner. And here we can see from the user perspective how this information is properly assigned to each user, right? The good question here is, okay, now we have 3 tasks. What happens when we create one more task? What do you believe that will happen, Karina, if I create one more instance of this process? One more instance of this task?
I don't know. Tell me.
Yeah. Since OptaPlanner is doing the assignments, and since we are trying to do a fair distribution of the workload between the users, with high probability, if I create a new task, this new task should go into John's list and not to Mary, because Mary has already 2 tasks, right?
Yeah.
So
indeed.
right now,
So you are saying that this assignment actually is based on some. It is not just round robin. It has some intelligence behind it. Okay.
Exactly. Yeah, good point. This assignment is not just round robin, but also optimized assignment. Unfortunately, it was complete for me to formulate a demonstration to show, all the things that you can combine, because there are many things that you can combine in order to provide an optimized plan. So, and I I have to say that I tried the demo for 3 times, and I could never finish it in the in the time frame we have. So I'm doing some simplification, but yes, this is not only round robin. This is optimized assignments. So if I create new task here, what we're gonna have is that the new task that was created went automatically for John, you see? And this is because when the new task arrived, OptaPlanner created a new plan, and it was established that the optimal way for completing all these tasks is by assigning this task to this user here. But let me create more tasks and start looking at what happened with the work distribution for the different users. I create one more task. This task now went, if you see this task, this new task went now for Mary. But if I create new task here, now it went for this user. And if I create a new task, for example, now it could have gone for Mary or for this user. Important thing here is that we have not only run robin, but optimized assignments. And if you look here, really, what we have is that these tasks here are still in the ready status, right? But these other tasks here are reserved. What do we? I will go into this because it's an important concept that we manage in OptaPlanner. But the idea is when you go to this automated approach, is that users should concentrate on the piece of work that OptaPlanner has reserved for them. So if you have an installation and you decide to go to and use the task assigning service, then in your installation, your users should focus always on the tasks that are reserved for them. This is the key point of the task assigning server, right? These other tasks here are already in the optimized plan because OptaPlanner knows already which could be the best distribution of the task between all these users. However, this task still remains in the ready status. It means that OptaPlanner has not yet assigned this task. You follow me?
Yes, we are.
Okay, thanks. So let me go back to another slide and try to explain what we are talking about. Right now, we have this situation. We have a lot of tasks in the system. We have some tasks in gray here that are already reserved and already assigned, right? And we have some tasks that we could see that are still in the ready status, which means that these tasks are not yet formally assigned. OptaPlanner at this point knows exactly to which user we should assign this task in an optimal way according to the status that we have at this moment in OptaPlanner. But we still haven't produced the formal assignment. And the reason we do this is because when we work with real-time planning, OptaPlanner is calculating the optimized plan all the time. Every time, for example, one of these tasks change or a new task come into the system or a task is completed, OptaPlanner is doing all the calculations again. And the explanation is that if you change the context, then the solution might change, right? And what we want is that always work on top of the last optimized plan. So imagine here that we have this situation and we have that a new task has arrived, right? Here we can see, for example, that the task 8 at this moment is assigned to the user Mary. When this new task arrives, what we will have is that OptaPlanner will detect that a new task was produced and a new optimized plan will be calculated. We are not only doing this load balancing, this that you referred to, right? We are also optimizing. So maybe when this new task arrived, the context has changed, and maybe now the best plan says that now task 8 should go to another user. You see?
So, Walter,
Yeah.
Does OptaPlanner also reassign tasks that were already assigned just to optimize the plan?
Exactly. That good
Okay.
point, Karina. So these tasks in gray here are the assigned tasks, the
Uh-huh.
formally assigned tasks, the reserved task. This is what we call in OptaPlanner the published task. This published task we will never change,
Oh.
because if you imagine that your boss come to you and say, okay, Karina, do this and this, and then your boss comes 5 minutes after and say, no, 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 Karina, now the plan is that you have to do this and this, and you
Yeah,
change
that's not
completely.
good.
You follow me?
Yeah.
So, but we don't want to change the work that was already reserved to the user, but we still want to give the chance to continue improving and improving the plan. So by using this strategy, we are only reserving or publishing a piece of the plan. This piece of the plan will never change. And users normally will concentrate on start working on this task. And this is not a problem, because as soon you complete one of these tasks, OptaPlanner will recalculate the plan and assign you more work, right? This is something that we saw in the slide before. So this is not a problem. Normally, the piece of the plan that we will publish is about. It depends on the installation, but it's about 2 tasks, 3 tasks or so. Because at the end of the day, if I give you 20 tasks, there is no way that you can do it all the tasks at the same time,
Yeah.
right?
Mm-hmm.
So this is the explanation about why we are having this effect here. And now let's start playing with one of these users, and double check what's happening here. Imagine that John start working, right? I will change to John here. So here we have the tasks for John. Right, if I complete, for example, let me pick this task here, that is the one here. I complete the task, right? When I go back to the task list, I automatically has new tasks again, you see? If you look into OptaPlanner, what's going on, this is what happened. Uh, OptaPlanner got one more task, but also the other ready task was already redistributed according to the optimization criteria. I will continue working with John to complete this use case. If John complete one of these tasks here, for example, what we will have is that OptaPlanner will calculate the optimizer plan again, and maybe OptaPlanner can decide that probably this task or this other task should be assigned to John again. So let me complete, for example, this task here. So look what we have. John got another task, and still we have a ready task here, and so on. If John complete one more task, this time OptaPlanner will detect that there are only that John completed one task, so he have one task of room in the planning window, and OptaPlanner will detect that we have a free task here. So the natural assignment that OptaPlanner will do is to try to assign this task to John. And here we have the assignment. You follow me?
Yes.
Okay. And this is very, very summarized what the integration is about. The important thing that we need to keep in mind is that when you use this integration with OptaPlanner, we are changing the way to work with the processes. Now users will rely on the tasks that are reserved to them by OptaPlanner. The optimizer plan is calculated many times. for example, I can do it right now, but for a matter, I don't have a friendly UI to do it. But if you change the priority for the task, you will see that OptaPlanner is also arranging the plan. And the important thing to keep in mind is that all this distribution of the tasks that we saw is based on an optimization that is performed by OptaPlanner, and we don't have only round robin. What we have is a real optimized plan calculation. Unfortunately, I maybe couldn't explain the fact of the round robin well, but this is how this works. Now I will use a more complex process, because at the end of the day, what I'm using now, Karina, is only the task definition, right? It's only the semantic of the process. If you see, we have that the task for manager is declared for the group managers, right? And we see that Mary is a manager. And this is right now, this is the only information that I'm really using for the calculations. I will use another example now and try to show how things start to becoming more interesting when we start using business information for the planning calculation. Okay?
Okay, let's go for it.
Okay. I will use another process, also simple, but I think it will be interesting to see what I'm trying to talk about. This is a very simple process, right? Resolve the credit dispute process. Imagine that you have a credit or a debit in your credit card that you say, no, I never bought this thing, right? Normally, you need to go to your bank or your company and complain. If you don't complain, you will never get the money back, right? This is something we know. So this process, for example, has a first user task that will resolve the dispute, will try to resolve the problem, and we have a second task that will be used for notifying the customer the result of the credit dispute. Maybe we get your money back, maybe not. But the important thing is that this example process is configured this way. We have that the resolve dispute task. If you look at the task configuration, we will see that the task is defined for the credit analyst, right? It means that in order to work with this task, you need to be a credit analyst. This is right ahead. Here we are in the, let's say, in the standard semantic for defining user task. But here we have more additional information. This is what I'm doing here is giving input data to the resolve dispute task. And the input data that I'm giving to this task, here I'm telling the task that the skills that will be required in order to complete the task are the credit card that you selected for this process. You follow me more or less?
Yeah, we are.
Thanks. If we go to the other task, we can see that the task must be completed by a client relations users. And here, by using the task input data, we are declaring that for working on this task, you need to have the proper skills in the language that the user selected when the process was started. And the important thing is that this information here is not static information. This configuration here is static because all the instances of this task must be executed by a credit analyst. But when we go to this configuration here, really the behavior of the process will be different depending on the credit card you selected. And the same here, because this information is dynamic. Depending on the parameters you gave to the process, the skills might have a value or another.
Walter,
At the end you follow me?
Yeah, so here the important thing for those who are going to develop is to always use the name of the variable as skills, right?
Yeah, for example, this is not mandatory. What I'm using here is, let's say, the by default constraints that we configured OptaPlanner with. Because, this information here is very easy to use because
Yeah,
it's generic to whatever process. But this information here is really related to your business. You can use there whatever information related with your business. So in order to have, let's say, an initial configuration of the task assigning service, we are providing some by default constraints and rules, right?
yeah,
So so the answer is yes. The reason why I'm using this name there is because I'm using the by default constraints that are already delivered with the service, right?
perfect. Thank you, Walter.
Okay, so when we go, so here we have a clear example. If I start a process that is for Visa, then I am saying that to resolve this task here, you need skills in Visa, and the same for the language. So let's see it. I will. Important thing right now, if you see, I have no users here, right, related with this process. I have no client relations, no credit dispute resolvers. So what I will do here, I will create some users on the fly, and we will see how OptaPlanner, thanks to the real planning techniques, can incorporate new users to the problem and not only tasks. This is something interesting in OptaPlanner. In order to work with your problem, thanks to the real-time techniques, we can combine different pieces of information. We can add new users on the fly and also new tasks. So it is everything. And right now, I have the task assigning service grabbing the user from a relational database, right? So what I will do, don't worry too much about this, but what I will do now, I will go to my relational database, you see here, and I will declare that all these users are now enabled. So what we will have here is now that when OptaPlanner, because OptaPlanner can also take care about the user's information. So when OptaPlanner when I refresh the status in OptaPlanner, we can see that we have new users here. You see? You follow me?
Yeah,
Okay.
we are following.
Okay, thanks. So what we have here is that we have 4 new users. And here we can see the second line that I was referring to. What we are telling OptaPlanner now is that this user here is a credit analyst, but also that this credit analyst has skills on this type of credit card. And here we are telling that we have a new credit analyst with skills in master and city. And here we are declaring new relation users with different skills in languages. Of course, here, depending on your process, a skill could have been, I don't know, Java, Perl, if you are working with a recruitment process or whatever, I don't know. So now let's go back to the UI here, and I will create some instances for this other process, and let's take a look at how OptaPlanner start doing the assignments, but also considering the business related information. I have already the process prepared. So this is what I was referring to. If you can see, these are the input parameters for the process, right? So I will create an instance of the credit dispute process, and I will tell the process that the credit card is blah, blah, blah. But I would say, for example, that this credit card, this process is for Visa. And for example, that I want my communications in Spanish. Okay. Let me start anyway, because we have also the chance to refresh this automatically, but let's go this way. Okay, we created the process instance. Now, if I take a look into OptaPlanner's memory again, then we can see that a resolved dispute task was created, and this is perfectly fine because now we are at this point in the process. But we can also see that the task is reserved. This is good because we are already calculating the plan and assign it to the users. But we can also see, look at this matching here. We can see that the task is for the credit analyst. This is good. And we can see now that we are matching the skills too, right? And here is when I believe things start to become more interesting, because here is really when you can start playing in your constraints and telling OptaPlanner how to produce assignments and how to optimize, but also by using business information related to your particular process. Now we are at this point here, right? So let's go to the task list again. So if I go to the analyst one, it's expected that I should have a task assigned for this user. Right? I have the task here. The task is reserved, all good. We can see the task information. We can see that the task is for Visa, Spanish language, skills in Visa. When I complete the task, what we expect that happens behind the scene is that new instance of this task is created and properly assigned. So when I refresh again the information in OptaPlanner, we can see that the expected instance was created. It's also reserved. And if we look here, we can see that OptaPlanner also considered the required skills for the task. So in this other simple process, here is when we can start looking at the value of OptaPlanner. Because, okay, you can use OptaPlanner only by using the process semantic. We can see that OptaPlanner can consider these kind of things here, right? We need to match the process semantic, but we can also start considering the business information related to the process in order to produce the assignments. And this is more or less what I have to show in terms of the I don't know how where are we in the time, Karina?
I think we still have something like 12 minutes, so
12
it's okay.
minutes. Okay. So I will, to finalize the
Wait,
more or less
don't finalize. I have a couple of questions.
Yeah, no problem.
So
Okay.
one thing, I am still sharing your screen, okay? So one thing, we saw on the first demo that when you create a lot of tasks, we can only have 2 automatically reserved.
Yeah.
Is this number of 2 tasks predefined by OptaPlanner? Is this like the maximum number of tasks that will be reserved?
Very, very good question, Karina. This number of tasks here is the size of what we call in OptaPlanner the planning window. Is the size of this thing here. Is the amount of tasks that we will publish, and this is something that you can configure. When you start the task assigning service, you can select a planning window of, I don't know, of size 1. So we will only reserve 1 by 1 per user, or a size of, of size, any other size. From the point of view of the optimization perspective, I think it's important to keep this size small, for this reason that I commented here, because really, if you keep this size small, you will really benefit from this effect here, that the tasks are continuously being reassigning according to the new context. When you reserve a task, we not reassign it anymore because it's not elegant. So the question is, yes, it's a parameter that you can give to the task assigning service.
Okay.
Second question, Karina. Thank you.
I also, can you go back to the service UI, please?
Yes.
Okay, thank you. So I see on the second demo,
Yeah.
the users on the bottom. Yeah, I see that the UI is actually showing like Visa, Spanish. So it is actually grabbing the variable value to display there as part of the categorization of the tasks.
Yeah, very good question, Karina. Thanks. This information that you see here really comes from the user system, not from the tasks. So I will show you the users definitions that I have in database right now, because I think it's a very good question. Uh, okay, don't suffer with this query, but more or less these are the users. I don't know if you can see them well there.
We can.
This is a relational database. We could find other ways for your user system, no problem. But look at here. What I'm declaring here is that analyst one is a credit analyst and that he has skills on Visa. Analyst two is a credit analyst with skills in City, and so on. So really, what this information here regarding the skills that a particular user has really comes from the user system, not from the tasks, right?
Okay, got it.
But this information that you see here really comes from the process. So what OptaPlanner will do for the calculations is to match information that comes from the user system, information that comes from the tasks that cares business related information, and combine all these things for doing the calculation of the optimized plan.
Okay, awesome.
Okay,
Yes,
very
thank you.
good question, because if you see, very good question, because this user system configuration is something that you can provide. You can provide your own component to the task assigning service in order to grab the user's information for wherever you want. For this example, I'm grabbing the information from a database, but you could eventually really grab the information from an LDAP, from KIELive. This is something that we want to do at some point. Provide a component to connect the task assigning service with KIELive, for example. This is something that we already have, for example, in the task console, and this is something that we would love to have for the task assigning service. I want to be honest, we don't have it yet. But yeah, so the interesting thing is that you grab your users from your user system with all the attributes and parameters that you have in your user system. And the processes are completely, the information from the process comes from the Kogito runtime, from a different place.
Can you go back to that slide where you showed how the integration works? The one with a small architectural diagram.
Yeah, sure.
Because I think that now that we've seen the demo, we need to go back here, because I think this will answer some questions here that I have on the live chat. So here we can see that we have the Kogito application on the left bottom. Then we have it emitting events to Kafka. So just double check the understanding, please, Walter. So
Yep.
whenever we start a new process and a new task is created, a new event will be sent by Kafka to the data index. In
Yes.
this moment, I'm sorry, using Kafka to the data index. So in this moment, the task assigning service will catch the same event that will be also captured by the data index, right? So
Yes.
one of the questions is like, can I assign multiple users at a time? So I think that as the tasks come, it gets automatically assigned, and a task can only be assigned to one person. So
Yes.
that's the thing, yeah.
Yes, I know that I knew that this question will arrive, so I have, let's say, a step-by-step example here.
Okay.
Look what's going on when we work with the task assigning service. this is the hello world process that I showed, right? The only task we have is the create for managers. This is the Kogito application that was automatically generated for us by Kogito. Important thing about Kogito, you don't need to generate an application, right? You only focus on defining your process, and Kogito will do all the rest of the job, right? The part of the job that Kogito can do for you is to create different endpoints in order to access and create the instances for your processes. This is one more thing that Kogito is doing for us, right? Because Kogito is designed for going to cloud, for working with microservices. This is not the traditional, let's say, approach that we have not all, but let's say former business process management system when you have a monolithic business process management service. Kogito is different. So this endpoint here was automatically generated for you by Kogito. When we create a new process instance by using the proper endpoint, of course, the process will create a new instance of this task because that's the process definition. Thanks to the integration of Kogito with Kafka, we will produce a cloud event. This is something also that you can use optional in Kogito. You can use it or not, like any other Kogito components. So a cloud event will be produced. This cloud event will be propagated along the wire to any interested party. In this case, for example, in the picture, I have the task assigning service, but also the data index service, but also the task assigning service. The good news here is that if you want to develop your own service and you want to integrate your own service with Kogito and start to be aware about what's going on with the tasks, with the user task in your Kogito processes, you can also do, because the only thing you need to do is to integrate your service here some way and start consuming the proper Kafka topics. So this event 2 here, really what happened was that the event arrived to the data index, but if you see here, it also arrived to the task assigning service. What we have here is that when the task assigning service detects the Kafka cloud event, OptaPlanner automatically takes control of this event, because really OptaPlanner is the brain of all this thing. So at this moment, we detected a change. We detected that we have a new task. OptaPlanner automatically takes control and produce the proper assignments according to the optimized plan. When we have this optimized plan, we execute the necessary assignment. Here is where we reserve the task that we saw before. For reserving the task, we are also using proper endpoints that were automatically created by Kogito for you, right? Sorry for being redundant, but when you go to Kogito, you don't have to worry about all these things. This is something that Kogito manage automatically for you. You only focus on your business, on your process, right? Yeah, so the assignment is produced. Yeah, sorry.
Here it is important to highlight that the assignment service, it doesn't work, it doesn't re-implement the wheel. It actually uses the service that already exists, so it decouples the responsibilities, and it's only responsible for doing the optimization plan. But when it's regarding the actual claiming, it just uses the service that it should use, that is the process service, the Kogito service.
Yeah, exactly.
Okay, so once it reserves, so why do I see an arrow from the service, from the task assigning service to the data index?
Yeah, good question. The task assigning service is something that you can use optionally in the Kogito architecture, right? If you want to go to the guided to the automated approach, you can include the task assigning service. If you don't want, you work as usually with the standard assignment. Reason why we have the data index also here is because the data index is the component in Kogito that is caring about indexing all the information from your tasks in your system. Let's say that the data index service is a kind of neighbor of this process, but doing a different function. The thing is that imagine that the data index service, that the task assigning service goes down, right? When we start the data index service again, we need to consume the information about all the tasks you saw in the system. If you remember when I started the demo, that the task assigning service was down.
Yeah.
But we had already created some tasks in the system. Let me see. Let me show you. Here, for example, we have this is an entry point to the data index service.
In that case, when you start when you start the service, does it do the assignment based on the events that it didn't consume, or is it doing the assignment based on the information that is in the data index?
Do it based on both things, but when we start, let's say that the data index is the source of truth that we have, because the other alternative could be to start consuming all the events from the beginning of time that you have in the system, right? But this is something that we don't want for performance purposes. So when the data index, when the task assigning service starts, we need to know what do we have in the system, and the data index is the Kogito service that is keeping the information about all the user tasks, all the processes that you have in your system. So when we start the task assigning service, we grab the information from the data index. But after we do this initialization procedure, we start relying on the Kafka events, because otherwise we should have to implement, any kind of polling strategy or whatever. So yeah, this is why we have the data index here.
Awesome. Thank you so much, Walter. So I will allow you now to wrap up your presentation, okay? If I have any extra questions, if you at your home now have any extra questions, drop it on the chat while Walter is going to finish his presentation, okay?
Yeah, please let me know, Karina, because I can see the chat now. So yeah.
One last thing.
Give me a hand there, Karina.
So, will you share the source code of your demos?
I can, but I want to be honest. I can't promise that it will be easy to start all this working.
Okay.
But yeah, I can. I will take a look how I can do to share all this in a way that you can start at this, because this is not a matter. This is not because this doesn't work. Really, what we have here is that if you look into Kogito, really you have a lot of things in Kogito. For example, in order to make this work, I need Kafka working. I need the Kogito persistent working. I need the data index. So in order to provide you with a very easy way to make all this working, maybe I need to do some Docker Compose or any other kind of packaging in order that you can start this only with one click.
Yeah, it's okay. We can work on this after.
Yeah, I can try to work on this, but I want to be honest. I don't have yet this packaged in a Docker Compose fashion or something like this.
Okay.
That you can start it on the fly.
They just want to see the process applications and etc. And also that is just one thing while you are switching to your last slides. This is the thing about the trade-offs of microservices architecture. So when using microservices architecture, this is what we got. So yeah, it is what it is. So please,
Yeah,
Walter, back to the
yeah,
presentation.
because yeah, yeah. If I would, yeah, exactly. This is one of the, when we go to microservices, we have many benefits, right? But also we need to know that all the pieces are things that have, let's say, their own life. They are going up and down by their own fashion. So yeah, I don't have a demo right now. I want to be honest there. Going back to the last slides, I just wanted to comment that what are the constraints that we are using right now in order to do all this calculation that I show. As I commented now, we need to provide, let's say, a by default calculation based, let's somehow in the process standard information, because we don't know really, the calculations might vary from use case to use case probably. So out of the box, these are the constraints that we are putting inside OptaPlanner in order to do the calculation. These constraints here are what we call hard constraints. A hard constraints is something that is a must. It's something that is mandatory. So by default, we have two hard constraints. One is a hard constraint that tells OptaPlanner that we need to respect the process semantic. If you remember the presentation, we don't want a task to be assigned to an intern if the task is defined for a manager. So this initial constraint we have here is to respect the process semantic. Another hard constraint that we have right now in this default implementation is the idea to meet the skills, right? So going back to this thing here, if we have a user task and we declare that for completing this task, we need a client relations user that knows Spanish, that has skills in Spanish, then this is a must for us. Because this is a way that we define it. You can change this definition, but this is a constraint that we are using as a hard constraint. This is what we call a hard constraints in OptaPlanner. It's something that we need to do yes or no. Then we have another constraint here. Forget about this. I will try to show you later. Then we have a soft constraint. A soft constraint means that it's something that is not mandatory, but it's something that you would like to have. So what we are telling OptaPlanner with these initial soft constraints is, okay, when you do this calculation, not only consider that the group must match and the skills must match if there are skills defined for that, but also try to assign the higher priority tasks first. Another constraint that we have in the next level of constraints is the decided affinity. In this definition, the affinity is pretty much similar to the skill, but it's different because we are not considering this as a mandatory constraint. With affinity, we try to model things like, imagine that I normally work with a particular customer, right? With a particular customer. So probably in a particular business, we want to tell OptaPlanner that when you have to assign a task that is for this customer, if possible, try to select Walter, because Walter, we know that Walter has an affinity with this customer. Then we have all these things with the fair workload and minimize baseline. If you see, this constraint is in the third place in this constraint here, fourth place, sorry. So here we can see that we are not only doing round robin, we are really doing optimization, because the minimization of the make span comes after the higher priority task first. So when OptaPlanner is doing the calculations, we will try to assign higher priority tasks first. Then, when possible, we try to minimize the make span. And the same for medium and lower priority tasks, right? So those are the constraints that we have right now in this default configuration, because we believe it's a somehow good set of constraints to start playing with and trying. But when you go to your own business, probably you want to add constraints that are particular to your business. This is something that you can do.
Walter, I'm sorry to interrupt you. We are over the time in 10
Yeah,
minutes. So,
yeah.
yeah, I think we can
Just to
stop.
finalize,
Okay,
in the slides, we can see that it's possible to do extensions in the task assignment service. It's possible to provide your own constraints. It's possible to provide your component for grabbing user from your user system. And there are other processings that you can configure when you go into use this. The links to the Kogito documentation are there. So if you click on those links, you are directly in the Kogito documentation, because this is a Kogito service, and you can start reading the documentation and playing with that. And thank you, Karina. Thank you, guys. I will go back to. Can I go back to the
yes,
screen,
yes.
Karina?
You can. I have stopped sharing your screen now. And
Okay,
Walter,
great.
this was an
So now I
amazing
can see you
session.
again.
Yeah.
Thank you so much, Karina, for having me here, and thank you to the people that took the time to attend to the presentation. Don't forget, join the Kogito channels, join the OptaPlanner channel in Zulip and in all the sources we have. Don't be shy, ask, and yeah, we are happy to to help you with whatever question you have with this service or any other. So I think it's all from my side, Karina.
Awesome. Thank you. This was a really nice session. My video has a little bit of delay, so please bear with me. Walter, I just like to tell folks here that we will be on Zulip chat and we can work on this demo on the source code and etc. Let's discuss this on Zulip and on how we can share it and automate it. Okay.
Yeah,
So
let's try to figure out how we can move this. Let's try to figure out how to move this forward.
perfect. So thank you, Walter, and
No, thanks to you.
see you all on the next KIELive. Bye bye, everybody.
Bye bye. Take care. See you.